for A max modulus, the concept is this. Say for example, I have a straight line, have a axis, so I have an axis, right? And let me copy this here. So if I have a straight line like that, the idea of modulus is everything that is below the y-axis, alright, it will be reflected up. So which means this one there will be a line up like that. So this is the final graph, and I have to make this dotted line or I have to erase away. So this is the idea of modulus. Okay. Now similarly, if I have a curve, the idea of modulus is anything that is below the y-axis will be shift up. So this one will go up like that, right? No, it's a solid line. Yeah. But then this part will be dotted line. Now what is special about this? So for example, if this is a negative 6, then this is a positive 6, something like that. So it will be reflected up. So far okay? Yeah, but then note that the point here, let's say this is 2, it will remain as 2. If this is negative 3, this is 4, it will remain like that. But the only thing that will change is the y-axis, the y-coordinate of anything that is below the y-axis.
Why will get concerned with move the solid downward?
Yes. So when do we move it downward? When do we move it downward? So for example, if this is y equals to, I give a estimate, let's say this is 3. So this is x plus 3, negative x plus 3 modulus. It will look like that. Okay. So far okay? Now, however, if I have y equals to negative x plus 3, now this negative actually means reflection downwards. So then your graph will look like that. Your graph will look instead of this, this will be reflected downwards. This will be reflected downwards. So it will be something like that. So this is, if this is 3, then this is negative 3. If this is 2, it remains as 2. So the idea of the negative will actually bring the graph downward. So this is the concept. Okay. Then now we go to how to plot, shall we? Okay. So the concept is number 1. If I have a straight line, it will be. Okay. Because this is the gradient, right? The gradient. No, I anyhow write the number. So, but then you understand the concept as the first one. If it's a straight line, then anything that is below the y-axis will go up. If it's a curve, then anything below that will go reflected up. If it's a negative like that, then first you will draw the modulus sign, then after that you will flip down. Okay. Now I pause the video here. Okay. So this part will be how to draw modulus. Modulus. So you need to take note of the x and y intercept. You need to take note of the turning point, if any. You need to take note of the range. Now, range means if I give you x is between negative 2 and 3, you need to sub in this number and tell me what is the y value. You need to sub in this number and tell me what's the y value. Okay?
Yeah.
Sometimes in question they will tell you what to calculate. So for this, in this case, sketch the graph this, but they didn't tell you what to do, what to write down. So usually I will find this 3. Okay. Now, so maybe I will give you, I will use a question in 1.4 part 1, question 12 part 3. Okay. I'll use a 10 series question. Okay. So I want to sketch y equals to 2x minus 3 square minus 4 with a modulus outside. Now the first way and the second way is slightly different. So I explain the first way first. Now the first way is to maybe I don't use A. I use this as method A, method B. So I use step 1. Step 1 is actually trying to sketch y equals to 2x minus 3 square minus 4. Right? So I try to sketch whatever is inside the modulus first. So I will use SILT, right? The shape is a minimum. The intercept, I try to find the y-intercept first. I put x equals to 0. So I put 0 inside, then this is negative 3 squared, 9. 9 minus 4, 5. So this is 0, 5. I just stop here first lah. Then the next one is line of symmetry. X will be equals to 3 over 2. Because I need this to be 0, right? X equals to 3 over 2. The turning point will be 3 over 2, comma, I put inside, it will be negative 4. Okay? So I have a rough idea what this graph looks like. I draw the axis, and then I draw the graph. 0, 5, I mark. This is 5. 3 over 4, negative 4. So it's somewhere here. And this is the line of symmetry, so I can go down, then I can go up, like that. Okay? I need to flip. Yeah, I need to flip. So then the next part is to actually settle for the 2x minus 3 square minus 4 modulus. So the modulus means I will move whatever that is here upward. So then my graph will look something like that. Now what is important is actually this point here. This point is 3 over 2 negative 4. So if I move up, this point will be still 3 over 2 but 4. Okay, so yeah, because the x should not move, but the y will be changed, right? And don't forget, either you erase this or you change it to a modulus. You are asking about turning point? You are asking about turning point? Yeah, turning point for curve, if you look at the bracket equals to 0, that will be to find the x. Then you sub in, then you find the y. Yeah. But later on I will explain part 1, why the lowest point on the curve has a coordinate this. But then I will explain it in a separate video. So part 2, the step number 2 is okay. Now step number 3, if any, if there's a range, for example, then I have to put it in. But in this question there isn't. So in this case, let me give a bonkers range. Let's say this is minus 4 and this is 5. So what I'll do, our sub x is equals to 4, negative 4 into which one? Do you think is equation 1 or equation 2?
Equation 1.
Actually both are okay lah. So if I put 2, then I'll have the final point ma. So maybe I'll put it with 2. So y equals to modulus 2 negative 4 minus 3 bracket square minus 4. So I press calculator. This will be negative 8. Wow, quite big. Negative 11 square. 1 to 1. 1 to 1 minus 4 will be 1, 1, 8. Is it? 1 to 1 minus 4. Wrong. 1 to 7. Whatever lah. So then this point here will be negative 4, and then this point here will be negative 4, 1, 2, 1. Something like that. 117. 117. Get the idea? Get the idea? Now the other one, x equals to 5. Then I have to sub in the same thing, put a point here, and then say what's the point here. Okay? So the first method is to actually draw the graph without the modulus, then try to flip it. So this is how you do it. Now the second method is actually trying to plot out points. So for example, you're going to sub in the x-intercept. So sub in the x-intercept means you will plot in y equals to 0, and you want to do it on the final one. So then this becomes 0 equal modulus, right? Then you try to put in. So you solve, then you will have x equals to 2 value, right? Okay. Then y-intercept, same thing. You sub in x equals to 0. So y equals to modulus 2x. You can remove the modulus because minus 0 plus 0 is still 0. Then this becomes 0. This becomes 0. Then minus 3 square minus 4. Then you solve the answer. Okay. Then after that, you have these 2 points already. then you need turning point because this is a curve,
Yeah.
right? So you need turning point. So turning point, still the same thing. You know x is equals to 3/2.
Oh.
But you need to put in with the modulus. So everything now is with the modulus. So you put in here, then you realize with the modulus you become 4. So with this, right, then you can actually try and draw an axis. So this is 5, I got 2 value here, and then I have a value, I have a negative 3/2 negative 4. Then with this, it's a bit difficult because you need to roughly know how it looks like. How do I connect all these points together? And the only way is by coming down, going here and coming up. Because there's no other way you can draw. Difficult, right? So that the only way is coming down and coming up. Alright? Now take note, I draw the wrong one for you. This and this, only one is correct because this is like convex, this is like concave, right? So the correct answer is concave. Concave. So these are the two ways to do it. One is by plotting point.
Always concave.
Yeah, always concave.
Okay.
But don't do it too obvious, otherwise it look weird. Just let it slant a bit. Now, so the second way is to plot point. The first way is to draw the original graph. Both methods are okay. So I leave it to you. And of course, don't forget the range. If there's a range, then you have to locate the two range. Okay? Okay. Now, for part 4, I look at A. It says state the number of solution where I have this graph. Yeah, so you notice that this is actually your y, right? So which means you need to draw y equals to 7. Yeah. So y equals to 7, create one line and make that line move. So you see, if this is 4, this is y equals to 4, y equals to 5, y equals to 7 is here. So answer is 2, because 2 intersection, can you see 2 intersection? So then first answer is 2.
Why you don't clean?
So number of solution 2, like that. B, y equals to 3. So again, is it 2? Y equals to 4 is here. Y equals to 3 is here. So 4. Answer is 4. So 4. So 4. Can follow? C, plus 2 equals to 0. This is 0 because you are drawing y equals to negative 2, right? Okay. So for this question, we are looking at solving A, B, and C. Now there are a lot of ways to do it. Plenty. But one of the easier way is by substituting. Alright, by substituting. Why do I say that? Because A and C are actually x-axis, x-intercept. So y equals to 0. So you put y equals to 0 inside, then you will have 0 equals to 3 minus 2x plus 1. So then you will straight away have 2 this, right? Then you can split into 2 equations. So itself is equals to 3, or negative itself is equals to 3. Note that I prefer the negative to be modulus. Go on. So straight away A and C is found. Now to find B, then it's a bit complicated. Okay. Now reason is this. You need to understand modulus. Now when I have this graph, what it means is I actually have two graphs. One is itself is positive. Sorry. Itself is positive, or itself is positive. So which means it's either the itself is negative or itself is positive, then you have minus or itself is positive, negative means it is a minus. There's a minus and then there's a minus. Can follow? You see how I derive that? Because itself is positive means 2x plus 1. Itself is negative means negative 2x plus 1. But because of the negative and the negative, you become positive. So what it means is I have actually two graphs that is combined together into one graph. So this graph may be this or this. This graph may be this or this. I don't care. But what I know is if I were to solve simultaneous, I'll be able to find point B. Full stop. Why? Because this one is representing one graph. This one is representing one graph. The meeting of the two graphs must be the meeting point, which is happens to be B. Intersection point of the two graphs. So you solve for that, you can get B straight away. Yeah? Then the last one, part 2. Solve the equation. This method I find easier to understand. Okay. Now, solve the equation this equals to x. So again, I have this. Very good. You realize that this is y. So actually they want you to solve y equals to x. Y equals to x means I were to draw one line just like that. Then I want to find this point. Yeah? So when they say solve, then your question is, Cher, I have two equations. Which one belong to this graph? Now, one easy way is to focus at this graph. I use another color so it's easier to focus. Yes. Now, this line here, the gradient is negative, right? Gradient is negative. So you look at this one. This is gradient negative. This is gradient positive. Oh, that means it's this line. So you solve this line with y equal x, and then you can get the 3 marks. Okay, I pause the video. Alright, how to find this point? Since this is the maximum point, I know this is 0, this is 2, this must be 1. I put 1 inside, I will have y equals to 1 bracket 2 minus 1. So this is 1. So which means this is 1, 1. I rephrase your question. Midpoint is line of symmetry. Line of symmetry always lies on the turning point, or the other way around. Turning point always lies on line of symmetry. Okay. Now, so I go on to the next point. So this is done. This is done. What else? What else? Okay, then we try and do 3. We try and do 3. Now, 3 is a bit unique because it says this thing here is equals to mx plus 1. Now, you do note that this is your y. And y equals to mx plus 1. So what then they are asking you is, in part A, it says m is equals to 1. Which means, what happened when y equals to x plus 1? So you're trying to draw this. Is it easy or difficult? Let's see. Now, y equals to x plus 1 means it's a straight line. And it will pass through 1 as at the y-intercept, right? Okay. So in this case, this green line must be like that. What? Do you agree? So find the number of intersolution, means intersection. There's 1 here. Is that all? 2. Because if this extend, you'll meet one more time. Now you just need to know whether it will cut here or not. If here, then you will 3. If no, you'll be 2. Never be, right? Because it's 1, right? So you cannot cut that line again, right? So the last one, part 2, B. B says I want to m equals to negative half. So y equals to negative half x plus 1. So this one, it means what? It's a downward line, right? And plus 1. Plus 1 means still here, right? Half. Half means if this is 1, then the runway will be 2, right? So then you'll be minus half. So which means if this is the y-intercept, this one will be the x-intercept. Can follow? Okay, don't follow, never mind. You use okay. You use a substitution to find the x-intercept and y-intercept. Do you follow? Again, you use substitution to find x-intercept and y-intercept. Example, y-intercept, I sub x equals to 0. Put inside, I get y equals to 1. So I know this is 0, 1. Then I have my first point. You follow?
Then
I sub y equals to 0. I sub y equals to 0. Then I get x equals to 2. Oh, I know this is the intercept. So by joining the two lines, roughly I will know that it cut 1, it cut 2, it cut 3. So then the answer is 3 for this and 2 for this. Any question? Isn't it negative 2, your question? Let's try. Y equals negative half x plus 1. I sub x, y equals to 0. So this is like that. Right? I bring this to the other side. So half x equals 1. So x equals 2. So then I get this point.
Right.
Clear?
Yeah.
Okay. So can I close the video here?
Yeah.